Imagine looking on the horizon and witnessing a sunrise that occupies half the sky. NASA has released images of a never-before-seen phenomenon where a star named Betelgeuse blew its top off, ejecting a gigantic portion of its surface mass. The event is known as a surface mass ejection, SME, and according to the Space Agency, the ejection was 400 billion times the mass of an ordinary solar flare from our Sun. Scientists describe the event as watching stellar evolution in real time, with a star blasting off such huge chunks of its physical form. Surprisingly, the catastrophic explosion of this super red giant is upsetting much of what we know about the universe. Why did Betelgeuse blow off its top, and how will that affect the universe? Let's find out. Constellations are made up of many stars and are arranged in accordance with mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant ruby-red glittering star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. When viewed attentively, though, astronomers recognize it as a seething monster with a 400-day-long heartbeat of regular pulsations. Because of its dismal orange-red color, Betelgeuse is easily identified. It is ideal for convincing doubters that stars do, in fact, have different colors. It is also known as Alpha Orionis and is the second brightest star in the constellation after the blue supergiant Rigel. Despite Rigel being brighter, Betelgeuse is Alpha Orionis due to its name, brightness, size, and reddish hue, making it one of the most well-known stars. It's noteworthy that this star served as the model for both the character and the movie Betelgeuse. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and it is the 10th brightest star overall in the sky. Earth is relatively close to Betelgeuse. Astronomers are unable to pinpoint Betelgeuse's exact distance from Earth, although they believe it to be between 400 and 724 light-years away. Betelgeuse is the brightest red supergiant star and is closest to Earth in our galaxy. There are just 200 red supergiant stars that have been identified. The Sun has a radius that is around 764 times larger than Betelgeuse. If this star replaced our Sun in the solar system, it would reach past the asteroid belt and even beyond Jupiter, suggesting that Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is 16,128 times as massive as the Sun. This supergiant has 126,000 solar luminosities and is visible from 548 light-years away. The star has a surface temperature of about 3,600 Kelvin, making it cooler than the Sun. Only about 13.3% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would overtake Sirius as the brightest star in our night sky. Betelgeuse loses about one solar mass every 10,000 years. The red star is surrounded by a nebula because this material is being ejected unevenly from the star in all directions. A cloud of material 250 times larger than the star surrounds Betelgeuse. The size of this nebula is also thought to be 30 astronomical units, or 30 times the solar distance between the Sun and Neptune, the furthest planet in the solar system. Our solar system's Sun regularly ejects mass into space, known as solar flares. However, the Sun only exhales tiny fragments of its outer atmosphere known as the corona, giving the phenomenon the name coronal mass ejection, CME. As a result, coronal mass ejections and surface mass ejections can occur at separate times. When a star ejects a portion of its unstable outer atmosphere, it causes a CME known as the corona CME. Coronal mass ejections from our solar system occur very frequently and can impact Earth and its inhabitants. CMEs can travel more than 1,800 meters per second while ejecting magnetic fields and plasma into space, occasionally arriving on Earth in a matter of hours. A CME can disrupt and harm Earth satellites and power infrastructures when it occurs on the side of the Sun that faces the planet, and it occasionally puts astronauts in orbit in danger. The recent discovery sheds light on the exceptional cause of Betelgeuse's event. In 2019, the material that the star ejected exploded into space, cooled, and produced a cloud of cosmic dust that hid Betelgeuse's brightness from Earth-based observers. Additionally, Betelgeuse's renowned steady pulsing pattern has been altered. The CME on Betelgeuse is unusual because it released 400 billion times more mass than a typical CME, which caused the star to tremble like a dish of gelatin desserts. According to a NASA news release, Andrea Dupree, an astronomer at the Center for Astrophysics, stated that the star's internal convection cells may be in disorder while the photosphere, which is what we perceive as the star's surface, struggles to reconstruct itself. Astronomers have been tracking the star's constant pattern for the past 200 years, yet it no longer exists. All red giants, including Betelgeuse, are perishing, and being able to observe this process will allow researchers to learn a lot about the evolution of stars. The majority of stars in the cosmos are powered by nuclear fusion, which eventually burns out and causes a star to undergo a series of intriguing stellar changes before it finally perishes. When a star is born, it is made of hydrogen, which, under the force of gravity, fuses together in the star's core to create helium. In a nuclear explosion, a lot of heat and light energy is typically released during the fusion process. This energy travels to the star's surface and is released as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium starts to combine with carbon to form carbon. After the helium is used up, neon will eventually combine with carbon to form iron. When this happens, the fusion of neon with iron absorbs energy instead of releasing it because there is nothing to oppose the star's very powerful gravity. When iron begins to fuse, the star collapses in on itself, giving rise to a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change hue during the course of their existence, from the youngest, hottest blue forms to the older, cooler red varieties, depending on what stage of their stellar evolution they have reached. The Greek scientist Timaeus, in 168 AD, strangely referred to Betelgeuse's color as having a ruddy appearance. 3 centuries earlier, Chinese astronomers had characterized the star as having a yellow appearance, possibly implying that Betelgeuse was formerly a yellow supergiant. Astronomers may gain a better understanding of how red stars lose mass in their last days before exploding in a bright supernova from Betelgeuse's explosion. As one astronomer noted, "We've never seen a huge mass ejection on the surface of a star before. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We're witnessing stellar evolution in real time." However, it's unclear whether this development portends Betelgeuse's impending supernova explosion because the results are so unusual. NASA issues a warning that Betelgeuse may not have reached the end of its life, even if it is nearing the end. Cosmic time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the focus of intense study since the 1st century BC. More recently, a scientist by the name of Sarah Nance and her team sought to ascertain the potential timing of the supernova explosions of red supergiants like Betelgeuse to find out how a star that large would behave over time. Nance and her team ran multiple simulations using Betelgeuse as a model and then contrasted their findings with field observations. Why did Betelgeuse diminish suddenly and out of sync with its regular cycle when it won't likely explode for another 100,000 years? Betelgeuse was evicted from its home in the Orion OB1 Association, which comprises the stars in Orion's belt, and has been seen moving through the interstellar medium at a speed of more than 1 light-year. By mid-February 2020, Betelgeuse had lost about 3 times as much brightness, from magnitude 0.5 to magnitude 1.7, after beginning to decline sharply in October 2019. By February 17, 2020, Betelgeuse's brightness had been stable for almost 10 days, and the star had started to brighten once more. However, Betelgeuse appeared to have stopped dimming completely 5 days later, effectively ending the dimming episode. Given that there were no significant changes in the infrared on February 24, 2020, it appeared that the recent visual fading was unrelated to the anticipated core collapse. Another study concluded that the star's dimming was most likely caused by a cloud of large-grain circumstellar dust. Dust absorption is ruled out from having a significant effect in a study that uses measurements at submillimeter wavelengths, but the fading appears to be caused by large star spots. Further analysis showed a dramatic rise in Betelgeuse's brightness between May and August. Betelgeuse is so close to the Sun that it is almost impossible to see from Earth. Before 2020, when Betelgeuse was in conjunction with the Sun, it was about -0.4 for brilliance. According to observations,